All right, so the other part of chapter 5.6 dealt with the logarithmic functions. I have the three integration formulas for the given chapter. However, really, we're only going to be using the top one. So I will deal with that. Again, I don't know that I've done these before, but so the natural log, the derivative of the ln of x is 1 over x, or x to the negative 1. So the integral of x to the negative 1 is simply ln of x, and then plus any constant, of course. All right, so here's a couple problems I've chosen from section 5.6 on page 605. Problem 329 here is kind of a classic way to do natural log. You'll probably see this a lot if you have to do it. You have a situation where you have a natural log to something, and then essentially an x in the denominator. So the easy way to do it here, and again, our typical strategy is to find what we have, the root, the square, or the cube, or the e to the whatever, or the function of something, choose what's inside of that as the u, and here it's going to work. So we're going to let u equal ln of x. And we find that du is going to be 1 over x dx. Well, we have a dx, and we have a 1 over x. So this equals the integral of 1 over u squared du. And this, again, is set up with our power rule, and we can evaluate this pretty easily. So we have u to the negative 2, which equals, we add 1 to both, so negative 2 plus 1 is negative 1, so it's just going to be negative u to the negative 1 du. When we put it back in and put it on the bottom, we have negative 1 over ln of x. And again, if you take the derivative of that using quotient rule or whatever you want, you're going to get your original, excuse me, let's see. All right. Now, 333 looks intimidating until you just kind of simplify it beforehand. So let's do that. So cosine of x, x cosine of x in the bottom, I'll break this into two fractions here. This is equal to cosine of x over x cosine of x minus x sine of x over cosine of x. Excuse me, x cosine of x. All right, well, our first fraction there reduces nicely to 1 over x. So I'm going to bring it down here. And I'll break it into 2. So 1 over x dx, which we can do. And then, well, we have the x's cancel. Sine over cosine is simply tangent. So integral of tangent. Okay. Now, what do we do with this? Okay, so you know what? I'm going to leave this as sine over cosine. I think that will be easier for us, at least to visualize. All right, so the x's cancel in the second part. We have sine over cosine. Okay. Let me scroll down a little bit. Well, we don't need a u substitution for our first one. But I'm going to leave it alone before I start into, well, no, that'll be fine. This is simply ln of x. And then plus some c. This one here, however, we're not going to integrate just yet. We're not going to need a u substitution. All right, so we're going to let u, We'll let u equal cosine of x. Which makes our du equal the negative sine of x dx. Well, we happen to have a negative, we happen to have a sine, we happen to have a dx, so that's simply now plus integral of 1 over u du. All right, so I've already taken the integral of the first part, so we leave that alone, and I'll put that there. And then this, we have a 1 over u situation, which is just ln. We'll combine the c's into just a regular c. This is ln of x. When we replace ln of, we replace the u with what our u was, it's cosine, so ln of cosine, and then plus c. So again, it looked kind of unmanageable because there's nothing to substitute as it stood in the beginning. But once we broke it into two pieces, again, the first part was fairly simple. The second part involved another substitution, but not terrible.